Hi, second grade. Man, oh man, we have been just tackling these subtraction problems like champs, and we're going to kind of change gears a little bit for these next couple of days to add and then do some two-step problems that I'm really excited about. Let's go ahead and take a peek at our learning target, and then we're going to get started today. I can add two-digit numbers using place value. Looks familiar, doesn't it? Yes, this has been a learning target we've seen a couple of different times. Tell me, what do we know already when we're looking at that learning target? Absolutely. So when we look at that word value. The value is how much something is worth. Yes. So place value is the value of the place of a number in a two-digit number. So if we have a two-digit number, then we have a tens and a ones, and our number in the tens place is worth 10. So if we have 43, then our 4 in that tens place is not worth 4. It's worth 4 tens, which is the same as 40. And our 3 ones is worth 3. We want to make sure that we know when we're looking at these numbers that our digits are very important, and the value of those digits is also very important. We'll be paying close attention to that today. Our story that we're going to be focusing on today is a story about a guy named Felix. Now, Felix has a collection of pencils and erasers, and he thinks that he has more pencils than erasers. For whatever reason, he thinks that. Do you agree? Why or why not? Now, before I can answer this question, whether we agree or not, we have to figure out how many pencils he has and then how many erasers he has. So, good old Felix has 54 blue pencils, and he has 30 yellow pencils. Now, you might not be able to see my 30 very well, so I'm going to trace it with my black marker. Okay? So if he has 54 blue pencils and 30 yellow pencils, we want to first find out how many pencils does he have all together. We'll get to the erasers here in a little bit. What equation might we write to match or to help us solve this problem of how many pencils he has? What equation could we write? Yes, 54 plus 30 equals blank. And tell me why that would be a good equation to match this story. Our 54 represents our blue pencils. Our 30 represents our yellow. Yes, and that box, that unknown, represents the total number of pencils that Felix has in his collection. So whatever tool you use, whatever model you do, I want you to make sure that you're showing me how many pencils he has altogether. And I want to make sure that you're paying close attention to that place value, the numbers that are in the tens and the numbers that are in the ones to help you solve it. Go ahead and get started, and we'll come back together here in just a few minutes. What model are you using to help you solve this? What are you adding first? Why are you adding your 5 and your 3 first? What place are those numbers in? What will you add next? So how will you find your total or your sum? How would you be able to write that in your equation, with equations? With that number line, what number are you starting with? How are you going to find your unknown? What are you doing next? Why are you making jumps of 10? How many jumps of 10 are you going to make? So what is your total number of pencils that you have? What place changed when you were adding that way? You're using equations. How did you break up 54 when you were writing that equation first? Why did you break it up into 50 and 4? 5 tens. 50. Okay, and then what about 30? How would you show that? Coming together here in just a few minutes, friends, few seconds I should say, we're going to wrap up what we're doing. If you're at home, please feel free to pause that video and give yourself some more time to solve your problem. Let's go ahead and start with that model with our base 10 blocks. When you drew your base 10 blocks, how did you show that? How did you solve it with that? Why did you draw your T-chart? That does help organize our thinking a little bit, doesn't it? With those 10s and those 1s. So what did you draw first when you were using your base 10 model? And why 5 10s? Okay, because there's 5 10s and 54. Okay, and how many 1s did you draw? And where did that 4 come from? That 1's place. Okay, and what did you do next? Why 3 10s? Because in 30, there's 3 10s, and then how many 1s? Ah, why 0 1s? Ah, because there's a 0 in that 1's place, okay? And so what did you do next? Ah, you said you know that 5 and 3 makes 8. So 50 plus 30 equals 80, okay? About 10, 20, 30, 40, 50, 60, 70, 80. And why do we count those by 10s? Because they're in the 10s place. That's value, right? The value of each stick is worth 10. And then what did you do with your 1s? They were only 4. Why were there only 4? We didn't add any to that, did we? And so what is your total? 84. So how many pencils did Felix have in his collection? I'm seeing some friends out of the corner of my eye, wiggle, waggling. They got 84 too. Who got 84 at home? Did you solve it the same way? Some of you did something a little different. Somebody in here did something a little different too. They were actually counting on, skip counting. What did that sound like when you were skip counting? What did you start with? Why did you start at 54? Is your bigger number? Okay, what did you do next? I love when I skip counting, I think about that number in my mind. What did you say next? 64, 74, 84. Why did you stop at 84? You were skip counting by 10s. Okay, so this is 10, 20, and then 30. Ah, okay, so your 54 is here. Where's your 30? In these 10, 20, 30, because you're skip counting by 10s, right? And you land on 84. Did anybody else skip count either by skip counting in their heads or using a number line to help you skip count, making those jumps of 10 and just knowing what comes next? Did anybody use a hundreds grid and picture that in their mind and go down? It's another tool you can use, isn't it? So when we did that, what place changed? Both of these, we have 84. What place changed? Why was our 10s place the place that changed? We had a 5, and then when we added to it, we got 8. We had an 8. Because there's 3 more 10s that we're adding on. But did the 1's place change as well? Why didn't the 1's place change? You can see that so beautifully in this model. Right? There were no other 1s that we were adding to it. Absolutely. Now, friends, he has 84 pencils, and he thinks he has more pencils than he has erasers. Let me tell you how many erasers he has, and then you're going to tell me if you agree with him or not. Now, Felix, good old Felix, he has 2 different kinds of erasers. He has some sports erasers, and he actually has 34 sports erasers. So some of his erasers are shaped like footballs, some are basketballs, some are even soccer balls. He has 34 of those sports erasers. And he has 50 animal erasers. You know, like a cute little pig, little piggy, little bunny maybe even, okay? So he has 34 sports erasers and 50 animal erasers. We want to know how many erasers does he have altogether? What equation might we write to match this problem to help us solve it? Okay. And why would that equation help us solve this problem? He has 50 animal erasers. He has 34 sports erasers. He's trying to find out how many there are altogether, so we are going to add them. And there's that box for the unknown. We don't know how many there are altogether, so we still have to figure that out, don't we? Ooh, I'm seeing some friends lighting up their eyeballs as they get ready to solve it. They're like chomping at the bit for me to say, all right, go, work. Because I think they might already have an idea. Go ahead and get solving, friends, and we're not going to give you very much time to work on this. Go ahead and see how many erasers Felix has. Go, go, gadgets. What do you notice about that? Oh, there's the tens are the same. What do you mean the tens are the same? What else do you notice? So what would that tell us about the sum or the total of erasers? Can you draw a model to prove that to me? What do you notice about this problem? Absolutely. And how would you show how you would solve that? How you were doing this before, how would that look? What would that look like if you were doing the same thing with this problem? 44, 54. Very good. Keep going. I love your model. How does that model show or help us solve that problem? What do you notice in that model? Absolutely. All right, friends, coming together. I told you I wasn't going to give you very much time. Okay, we're going to do the same colors, same way. My friend over here, and actually I have a couple friends, who else used a base 10 model to help them solve this problem? At home? I love seeing that. That base 10 model is really helpful sometimes, isn't it? When you did that, though, what did it look like? Okay, and then what? Okay, and so where's your 50 in that model? Okay, and what about your 34? 34. And what did you notice? It looks very similar to this over here, doesn't it? How's it different? The 4 is just moved, isn't it? We still have 80 in tens and 4 ones, and we still have 84. We still have 5 tens and 3 ones. We still have 5 tens and 3 tens, and we still have 4 ones and those 0 ones. Interesting. My friend that counted on, you did something very similar, but where did you start this time? Why 34 instead of the bigger number? You could skip count by tens. Can I have everybody do that with me? If we're skip counting by tens, how would that sound if we started at 34? 34, 44, 54, 64, 74, 84. What place changed, my friends? The tens. 10, 20, 30, 40, and then there's that 50, right? So we're still have to add 50 to that 34. I can add whichever first, can't I? Because we're adding those numbers. It doesn't matter which one goes first. So what do you think? Do you agree with Felix? Does he have more pencils than erasers? Why do you think he is wrong? Wrong-o. They're equal. They are the same. So when we look at this equation, these two equations, or these two expressions, I should say, 54 plus 30, and 50 plus 34. What symbol could we put in between there to make this true? If this is not more and this is not less, or this is not more and this is not less, what symbol will we put in the middle of that? An equal sign. That's right. If this and this are the same, then that equal sign can go in between. Those are not the same numbers, but how did we know that they were the same? And some of you started picking up on that right away. The tens were the same and the ones were the same. They might not have been with the exact same number, right? Because the 4 was a 50 before and now it was a 30 over here. But when you're adding the two numbers, what's in the tens place and what's in the ones place didn't change. So I am going to pose a couple more of these to you. I've got some pairs of expressions to share with you, and I want you to think about what you notice about these. So our first one is 48 plus 20 and 28 plus 40. The other one I want to show you is 56 plus 40 and 46 plus 50. What do you notice about those pairs? What do you notice about those pairs? And friends, I want you to pay close attention to that place value, right? What is in the tens place and what is in the ones place? That place value, or the value of what that place, is super important when we're adding these two-digit numbers. What do you notice about them? What do you notice, my friend? 4 and 2 are in the tens place. What about the second part of that pair? 4 and 2. What did you notice? There's an 8 and a 0 and an 8 and a 0 in the ones place. So what would both of those equal? How do we know it's 68? Because 4 plus 2 equals 6, so 4 tens and 2 tens equals 6 tens and 8 ones. What about this guy over here, this partnership or this pair? What do you notice about it? Ah, yes, 6 ones and 0 ones. 6 ones and 0 ones. So how many ones are going to be in the sum? Right? Probably shouldn't put that symbol, even though I was just trying to connect those two. I just realized it makes it look like it's greater than, right? Oh, that's not true. We're going to have equal to, okay? What about the tens? 5 and 4. 5 and 4. And what does 5 plus 4 equal? 9. So 40, or so 5 tens and 4 tens equals 9 tens. They both equal 96. Friends, we know how we can skip count by tens to help us find the sum, especially if there are groups of 10, right? We have put our tens and separated our tens and our ones and then put them back together. And now we are looking at pairs of equations or expressions and noticing that if our tens places are the same and our ones places are the same, then it'll actually have the same sum. Is another strategy we're going to put in that back pocket that Felix probably should have known about, huh? He was not looking at those totals. All right, friends, we're going to continue doing some work with this, and tomorrow we will be diving into two-step word problems. So put on those thinking caps, and I will see you tomorrow.